Today we're going to talk about another type of three-dimensional figure, the pyramid. The pyramid may be one of the more famous three-dimensional figures because of the pyramids in Egypt, right? So this is a figure that's very well familiar to us, the square pyramid, but there's all types of pyramids. There's hexagonal pyramids, there's rectangular pyramids, there's triangular pyramids. So for our examples today, we're using a square pyramid, but know that you will see, and there are pyramids that come in all different shapes and sizes. The things that are consistent with pyramids, let's go ahead and just make sure that we're all on the same page. We've got the base right here. I mean, whatever that is, each pyramid has a base. And then a number, however many sides you have that many triangles connecting to a central point at the top. That's what a pyramid is. And yeah, so let's talk about finding the volume of a pyramid. The volume of a pyramid is 1/3 times the area of the base times the height of the pyramid. With the height of the pyramid being the distance from this point at the top to the center of the base. That's the height. There's some really great proofs on why the volume of a pyramid is 1/3 the volume of a prism. If you remember, the volume of a prism is just base times height. There's some great proofs out there I think you should check out on your own time. We don't have time to get into them right now. So that's the volume of a pyramid. Now, the lateral surface area of a pyramid. Remember, the lateral surface area is the area around, right? The surface area that doesn't include the base. So it's the area, the lateral surface area is the sum of all of the triangle areas. Okay, that's the lateral surface area. And so in order to find the area of a triangle, you might remember we do 1/2 times base times height. Well, we don't want to get confused here because we already have the height of the pyramid. So we call this L right here. We call that L, which is the slant height. So L is our slant height of the pyramid, which is just the height of a triangle. Okay, drawn on the pyramid, it would look like this. And that's not the best slant height I've ever drawn, but maybe we try that one more time. What if I give a line? Oh, whoops. It's not really wanting to cooperate right now. That's okay. So here we go. If we draw the slant height, it would look something like that, right? Is our slant height. And that's on the outside of the figure. Okay, so that's the slant height. So let's talk about what maybe a formula or how we can think about an easier way than just trying to find the area of each triangle individually. This looks like a square, but maybe let's generalize it and say that it's a rectangle, right? It could be anything. The four sides don't even have to be the same length, which maybe let's do that, right? Let's call all the four sides different lengths. Here's A, B, C, and D. And each one of them, just because the length of a base is different, the height of the triangle is always the same. It's always just L. Okay, so let's add all these together. Again, we're just trying to generalize a formula for finding the lateral area of a pyramid. So the lateral area is equal to the sum of all those triangle areas, which is 1/2 times the base times the height, which is L. So here, this triangle is 1/2 times A times L, plus 1/2 times B times L, plus 1/2 times C times L, plus, let's stay consistent, plus 1/2 times d times L. Okay, and that's a lot of stuff, right? But let's see what we can factor out of this equation. Each of these expressions has a 1/2 in common, so we can factor that out. And what else do they all have in common? Well, they all have an L in common, right? They all have that slant height in common. So 1/2 L times A plus B plus C plus D. Oops. Right? And what's another word for the sum of all the sides of a figure? The perimeter. So then this is 1/2 times the slant height times the perimeter of our base. And that's the lateral surface area. Easy peasy. Now, total surface area, it's harder to generalize a formula because we don't know what the base of our pyramid is going to be. Like I said earlier, it could be a square or an octagon or a dodecagon or any sort of weird figure you could think of. But the total surface area then is just, maybe we can get a different color. The total surface area is the lateral area plus the area of our base. That's the surface area, is just the lateral area plus the area of the base. So you could say that's 1/2 times the slant height times the perimeter plus the area of the base. And that's the total surface area for a pyramid. So that's all we got, right? We've got volume, lateral surface area, total surface area.